All right, happy holidays to everyone. It is almost Christmas and I am in the mood to do something fun. So I came up with an interesting little project that we are going to do here. I'm going to make a Christmas tree ornament that plays different Christmas songs when you walk by it using the Arduino. And it's pretty simple, at least I think it's going to be, based on what I drew up. So we'll see here. If you want to follow along, what you'll need is I'll be using an Arduino Fio for this project. You can pick one up off of SparkFun. I think they're like 20 bucks. Also, I'll be using a 2100 milliamp battery. This one, as you can see, is all taped together. It's from a cell phone. Just jacked it out of the cell phone. You will need some wires. There is a speaker. These speakers are really cheap. It's just a regular Arduino speaker. Just has a couple pins there. Sorry, the camera keeps unfocusing. I'm trying. Alright. And you will need a ultrasonic rangefinder. This guy's pretty fun. If you haven't played with one of these, I suggest you try it. They're not that hard to use. Basically, you just pump some power into it. It shoots out a sound wave, and then it captures it when it comes back. And then you can do some calculations on how long it took and get a range based on that. So what you'll need is 2 wires for your speaker. You'll need 3 wires for your ultrasonic rangefinder. I only have 2 here, but I'll explain why later. You'll need 2 wires to come out of your Arduino Fio, and then you'll need 2 wires coming off your battery to go into your Fio. And with that, we should be able to get started. So let's go take a look at the schematic. Okay, so you can see from my schematic here that I've drawn out all the different parts. We have our 3.3 volt battery here that is 2100 milliamps, and it's going to plug into the battery part of the Arduino Fio. If you haven't worked with the Arduino Fio yet, it's a really nice system. It has a built-in charging circuit, so it saves you a lot of the headache of having to worry about lithium-ion batteries exploding and such. Our Arduino Fio is going to be plugged into the speaker and the ultrasonic rangefinder here, or they're going to be plugged into the Fio at least. And as you can see here, what we're going to do is the speaker, the positive connection, is going to go to the analog on the Fio, so we can send it different signals and it can play different sounds. And that's going to be using pulse width modulation. If you don't know what that is, you should look it up. And then we're going to have the ground go to both devices here, as you can see. And the 3.3 volt is going to come out of the Fio and go into the ultrasonic rangefinder. And we're going to have an analog come out of the rangefinder as well. Now obviously this isn't the way the pins are set up on the board. It's just for schematic purposes. If you're curious why the power for the speaker comes out of the analog, it's because the analogs are powered, so it can receive power from there. Now we're going to get 2100 milliamps out of our battery, and the speaker is negligible. The ultrasonic rangefinder is going to be running constantly, so we need to account for that. It requires 2 milliamps an hour at 3 volts, so that's what we're going to be using. And the Arduino Fio is going to be using approximately 50 milliamps an hour. So we take 2100 milliamp hours divided by 52, and that gives us about 40 hours worth of battery life. Now the Arduino Fio also has an on-off switch, so if you're not home, you can turn it off. But basically what I'm going to try and do here is have it so when you walk by and break the specified range on the rangefinder, it's going to alert the Fio, and the Fio is going to play one of a couple selected songs through the speaker. And we're going to set those songs up in code, and you'll see how that's done. It's not too difficult, but you will need to figure out the song notes. I'll try and provide some resources, so good luck with that. Alright, so you can see here, I've gone ahead and done all the soldering. Now, you will take note that I did leave one solder undone. I did not connect up the negative from the battery to the Arduino Fio, and I did that intentionally. I've had issues in the past where if the battery's connected and you're trying to load a sketch onto it, that magic smoke will come out of your Arduino. I think it's because it's getting too much power. So I would suggest leaving the battery detached while you're trying to code onto it. But a couple quick things you'll notice here. In the past, I soldered my FTDI connector right into my Arduino Fio. I know it looks crooked, but it's balanced on the back. That's why it looks crooked. It's balanced in there. Nice solders. But yeah, so the thing that changed was I said in the code, or I said on the sketch that it was going to be analog 0 when actually it's analog 3, and you'll see that reflect in the code. I just want to make sure that we were clear before I moved on. But you can see there the 3 volt and the ground, the analog 7 and analog 3, and also the battery terminal. Now the ground right here, I have the ground for both the ultrasonic sensor and the speaker all connected in there, and it goes into the board, and then the power is distributed appropriately. So let's get started.
Okay, so now that we have our equipment soldered together, we can start taking a look at some of the code. Uh, like any good code project, we're going to want to do this in a couple pieces just to make sure that everything's working. Um, if you're familiar with coding at all, you usually want to break everything down into the smallest pieces, and when you're working with hardware, it's even more so. Okay, so the first thing I want to do is I want to make sure that the rangefinder is up and working, because this is going to be the easier part of the code. So as you can see at the top of my class here, I declared a rangefinder and I put it on analog 3. I declared a duration, and you actually don't need the two different ones here. These guys can actually go away. You just need that one right there. And see if I can bring our other screen back. Okay. You just need the duration long set up. So in your setup method, I want you to do a serial.begin 9600 baud, and we're going to go ahead and set up the rangefinder pin on analog 3 and set it as an input. Down in your loop, you're going to assign duration, and what you do is you do analog read, pass it in the pin of A3 or rangefinder, our variable. Don't forget to cast it to a long, and that will assign the duration. And the rest of this is just printing it out so you can see what the values are. So this kind of seems like an arbitrary number here, but I will explain this a little more in depth. What you want to do is you want to take your input voltage, which is in my case 3.4, I think is 3.43 or something like that. That's what I used the multimeter to figure out exactly what my USB port was putting out. When I switch this over to the battery, it's probably going to be a little bit less than this because it's going to be 3.3. But what you do is you take your input voltage that's actually going into the sensor, and you divide it by 512, and that will give you a decimal point like this. When I do 3.4 divided by 512, it gives me 0.00669921875, and I just rounded it off to 0.061. Now obviously the more decimal points you carry it out to, the more accurate you're going to be, but for this project it's fine if it's rounded off. So the first thing you do is that, and that will give you this number. Now the duration variable is actually not a duration. I I took this, I made this a hybrid from another snippet of code I had, and the variable name just stuck. But what duration actually is the it's the voltage that the analog pin is reading. It's not actually time between ping and receive. But yeah, so you're going to take the voltage that the sensor is sending back. You're going to multiply it by your 0.0067 or whatever your drive voltage is from the input voltage divided by 512, and then multiply that by 100, and that's going to give you your inches. Now, basic math, if you want to get feet, you just divide that by 12. And what you can see here in our output window, with our serial output window, is every second mine is reporting the inches and feet. Now if I put my hand about a half a foot or a foot and a half away, should be getting close to that, yeah. And I bring it closer, closer, closer. Now eventually you're going to get too close and it'll stop reading. I think between 6 inches and a foot is right about where it stops. Yeah, somewhere in there, yeah. So about 3/4 of a foot is the closest you can get, it looks like. But that should be fine for our purposes. I'm gonna probably put maybe a 4 or 5 foot range on it, so um, that should be plenty. But that's it. So if you're getting a similar result to this, then you're doing something right. The next step is we're going to code up the speaker and make it play a tune. And ultimately, what it's going to happen is your rangefinder is always going to be running like this, and somebody's going to walk by, and it's going to drop down, and then it's going to go back up. And what we'll do is we'll identify that drop in code, and we'll say play a song, and we'll have it choose from a list of songs maybe, and have it play. So before we begin going over the speaker code, um, I should just clarify real quick. Go back and desolder if you've already done your soldering. Go back and desolder the speaker from the analog 7 and resolder it back into digital pin 10. I searched and searched and searched, and I couldn't figure out why my analog pin wasn't working. It might have something to do with the way I was implementing it, but I think it has something to do with the analog pin on the Arduino Fio not pushing power. I'm not sure why. I have to look more into it, and I will post when I figure it out. If somebody knows, please let me know. That'd be nice. But for this exercise, what we're going to do instead is we're going to do it on a digital pin instead, digital powered pin. And on the Arduino Fio, digital pin 10 is powered, and that's what we're going to use. So once again, you need to connect the positive pin from the speaker to digital pin 10, and then the ground to the ground, or the negative to the ground. So let's get started going over the code. As you can see, we'll just start at the top. And so you know this is the complete code. This is with the rangefinder and everything built in. This is all of it. So you'll see everything you need here. But we'll start at the top and go through it. The first thing you'll notice is that I included the header file for pitches. This is built in. You just have to reference it, and you can start using it. And this is how you use it. I coded in 2 songs. I coded in Jingle Bells, and I coded in Frosty the Snowman. And I just did the first couple measures of music. You can do as much as you'd like. All I did was search for Frosty the Snowman, and I think I used piano and sheet music. Now, obviously, this helps if you have a background in music. I have a pretty strong background. I played instruments for years, so it's easy for me to read sheet music. If you don't know how to read sheet music, this might be a little bit of an issue for you. Um, but you can copy my example. I'll even post the code below, and you can copy it, and it should work. Um, but I will describe this as if you do understand sheet music. So let's get started. Jingle bells. This is referencing the pitches header file here. This is out of that, so there's no magic here. This is coming out of that header file. And basically what you're saying is you want to play a note. You want to play the note E in the fourth octave. So I tried playing it I started with 2 and it was way too low. It sounded demonic, so I brought it up to 4. And what you'll see is that in the fourth octave it sounds pretty good. And that's all this says. It just this is the notes in order as they are played. Now it's an array of ints, okay, and I can only imagine that under the covers, what it's actually doing is assigning it a value of like 200 or 300 or whatever the frequency is that it needs, and then that's probably the pulse width modulation that it's putting out through the digital pin, and it just translates to that sound. I mean, that's just a guess. I don't know if that's how it's working, but that's my guess. But yeah, so this is the notes in order, and it's just in an int array, and we have E, 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 so it's jingle bells, and then another 4 E's, jingle bells, and then E, G, C, D, E. So jingle all the way, right? Um, so that's the notes, and then here are the duration of the notes. So you have to imagine this is going to be 1,000 divided by this number. So 1,000 milliseconds, which is 1 second, which is one measure, which I think is 4/4, 4/4 time, if you know music. So this would be quarter note, half note, quarter note, half note, quarter note, quarter note, quarter note, quarter note, whole note. And these correspond directly to these notes. And when we go through the loop down below, that's how it'll work. Now, same for Frosty the Snowman. It's the same exact scenario. These are the notes. This is the duration of the notes, and we'll handle the rest down below. I will cover what that bool and this int are in a few moments. Nothing else in the setup. You don't have to worry about that. You can get rid of this. You don't need that. That was for demo that I was doing. Yeah, you don't actually need that. Otherwise, it'll play as soon as you turn it on, which is fine. It'll only play once, but yeah. This should look familiar. This is our rangefinder code. It's still, I left it at range finding every second. Should save on a ton of power. And I am saying here, we'll come back to what that does. So I have two methods. I have play Frosty and play Jingle Bells. So when play Jingle Bells is entered, or I'm sorry, invoked, it will set a boolean that says the music is playing to true. That way, if the range is broken here, if the range is broken while the music is playing, it won't start playing again. I actually didn't hit this bug. I just did it ahead of time. I don't know what would happen if you tried to invoke the method again. I didn't try it. I didn't care. I just figured it was a good practice to put a flag in there to say that the music was playing. So feel free to try it if you'd like, but don't be mad at me if magic smoke comes out of your speaker. I don't know how that works if you try and invoke two songs at the same time. So what it's doing is it's coming in here and it's the current note starts at 0 while it's less than the total amount of notes, and then note plus plus. So if you don't understand how a for loop works, you should go study that and then come back. If you do understand how a for loop works, this should make sense in a moment. There's some pretty good notes here by the person that actually wrote this sound thing here. But we're not going to pay attention to that. We don't care. So the note duration is 1 second, which is the length of a measure, divided by the current note in the duration array. So that should be pretty straightforward. It takes that note duration, passes it into the tone method, which is it's in the pitches header file. Where was that? Okay, so tone comes out of the pitches header file. It's on pin 10. This is the only confusing thing. I guess I could have declared this above to make it more explicit, but this is the pin that your speaker is on. It's pin 10. So saying on pin 10, I want you to play the note that is next. So whatever note it is, right, in our notes array for the duration of however long the duration was. So it'll play the note. It will pause between the notes for you with this. And then it does the pause, does no tone, which I'm guessing stops the tone of the music, and then it loops back up and plays the next note, and then it plays the next note. And then once it's completed playing, we set the flag back to 0. I'm sorry, the flag back to false, which I guess is 0. And then we set the last song played to 0. So I did this too, so I know which song played last, so I could cycle between them. There's probably a better way to do this, but this was just my 1 o'clock in the morning quick flag of showing which one played last. And then the same thing for Frosty. So the Frosty method also has, it sets the flag to true, cycles through the notes, plays the notes, changes the flag for music playing to false, and then sets the last song played to 1. And then up here you'll see that that's what it does. So it comes in here and it says is the range on the rangefinder less than 3 feet, so assuming somebody walked in front of it or put their hand in front of it. If it is, then it'll look at the last song played. It'll say if the last song played is equal to 0, which is Jingle Bells, and there is no music playing, then go ahead and play Frosty. Else if, or otherwise, if the range is less than 3 feet and the last song played was Frosty and the music is not playing, go ahead and play Jingle Bells. And it will play Jingle Bells, and then it cycles through. And that's it. The code is pretty straightforward. As is with most Arduino code, it's pretty straightforward, pretty easy to understand. If there's any confusion, it's because I complicated things. But feel free to ask me questions on Twitter if you have any questions about this. So this should all compile. I will post the code below the video, and you can grab it and stick it on your Arduino and see how it works. But let's go see how it looks.
Okay, so let's take a look at the finished product. As you can see, we have it all rigged up here. There's the speaker down there, and the Arduino Fio, and the battery. And then we have our rangefinder up here. So it is on, and it is running. So if I take my hand and I wave it over top, should get some music. There's our Frosty, the snowman, and if I wave my hand over top again, maybe, there we go. And you get Jingle Bells. And then if I do it again, you get Frosty again, and you can put any number of songs in here. But that's it. That's how it works. That's your very own Arduino Christmas tree singing ornament that plays when you walk by people. So I hope you guys enjoyed this tutorial, and I hope that you guys come up with some even better stuff than I can dream of, and I hope everyone has a great holiday. Thanks. ISO, what is that? What is that, huh?